Hey, my name is Greg Van Ameren,
My name is John Borvillas.
My name is Sean Giddings.
and today we'll be giving you some pointers and showing you how to conduct the tank drainage and siphon lab.
These are the pieces of equipment that you'll be using in this lab. You have two buckets, one that's empty, one that's filled with water, and it has to be filled with enough water so that the plastic tube that you will be using is fully submerged. You'll also be using two different graduated cylinders to determine which one's the most effective to use in this lab, and you'll be using a measuring tape and either a stopwatch or a phone with a stopwatch app. Okay, so before beginning the experiment, what you'll want to do is measure the length of the plastic tube that you'll be using. And once you're done with that, you'll want to measure the inner diameter of the plastic tube, and then for the schematics, you may have to take the outer diameter of the tube as well. Once you're done with that, you'll want to take the height of the water in your bucket, which will be important for later calculations. You'll want to take the inner diameter of the bucket, graduated cylinder, and you'll take the inner diameters for each one.
So before we actually conduct the lab, we need to do a propagation of error analysis to determine if we want to use a smaller graduated cylinder or a larger graduated cylinder. So we'll show you how to do the setup, but at this point, Dr. Hesketh will show you this equation, and it looks really scary at first. We had no idea what was going on in class. But basically, this is the term you're looking for, dQ over Q. The V is the volume of water that is collected in the graduated cylinder. T is the amount of time it takes. dV is the difference in volume between the lowest measurement points in this specific graduated cylinder. And dt is the amount of time it takes for the person recording to basically stop the stopwatch. So for dt, I would suggest stopping and starting as quick as you can and using the average of that number and keep that person consistent throughout your trials.
Okay, so when coiling the tube into the bucket, what you'll want to do is start by slowly lowering the end of the tube into the water, and then slowly wrapping it around the diameter of the bucket. And you want to make sure that no air bubbles go into your tube, otherwise it's going to cause the tube to float to the top.
Now we're going to show you how to remove air slugs and bubbles from your tube, because this was probably the hardest part of the experiment for us. So if you want to come a little bit closer, you can see I lowered it in too quickly, so I have an air slug at the top. So one of the keys is when you're lowering the tube in, you want to make sure all the coils are firmly against the bottom, because then any air bubbles will rise up to the top. So showing the method I just did by keeping the end of the tube at the highest point and the coils below, I was able to remove all the air bubbles, and we are now ready to move on to the next phase of the experiment.
Now, the next step is to pick your location to actually run the experiment. You're going to need to have two different heights for the buckets. So you can either do this in the lab itself, or you can do it in the stairwell. Each area has their own advantages and disadvantages. If you do it in the lab, it's a little bit more efficient, but you do risk some safety issues with the stair ladder. But if in the stairwell itself, you have to have your arms go through the rungs to transfer the tube from the top bucket to the bottom bucket. However, because there's multiple steps, you don't risk any health issues, safety issues.
This is physically conducting the lab. So you're going to basically take the end of the tube, and you're going to want to kink it so that no water runs out when you transfer it down to the bottom. When you do this, make sure that the coils stay intact. That's important for later on in the experiment. And what you're going to do is you need to achieve steady state flow before you begin collecting it in the graduated cylinder. So I'm going to let it run out a little bit into this bucket to achieve that. So you can see there's no bubbles going through. And I'm going to move it to the graduated cylinder. 3, 2, 1, go. Stop. Something important you need to do for each trial is consistently keep the end of the tube at the same height of the graduated cylinder, and I just choose at the top right here to keep it the same. You're going to want to fill the graduated cylinder. I filled it a little bit too high, but you choose a location below the top area to fill it to, and you have your time, you have your volume, you can calculate your experimental flow rate.
Okay, so once you perform the experiment once, you're going to want to take the water in the bottom bucket and use it to refill the top, so that way the water level is at the same point for each trial. So you're also going to want to know the distance between the top of the cylinder and the bottom of the bucket, so we can find the total height later. So you're going to do 3 trials for each different height, and you're going to try to do it for 5 different heights. So this height, for example, and then maybe a few more heights. It's also important to realize that you want to keep the graduated cylinder as close to the bucket horizontally as possible for each run.
So this is the setup if you're going to be conducting this experiment in the stairwell. Once again, you want to make sure that your coils are completely in the bottom of the bucket, there's no air bubbles, and I am kinking the hose right now, and I'm going to transfer it. And like we said before, this one is a little bit more awkward because you have to get it through the rungs of the stairwell, and at larger heights it can be really awkward. And as we said before, also you want to achieve steady state flow by opening it up first, here, letting any bubbles come out. And then, like you said before, we open the top of the cylinder, and as we also said before, you're going to want to have it fill to a certain height below the maximum recorded volume. So in this case, I'm going to go to about 950 milliliters. We're there. One really important thing, if you're going to be using this location to do your experiment, is you don't want to use a tube with a larger inner diameter, or there's going to be too much flow all at once when you begin to go larger in height. For all you who feel like you're suffering through fluid mechanics, it's going to be rough. It's a ton of work. Going to work like dogs, but I actually really enjoyed the class. I learned a lot, and I actually feel like I can do stuff in real industry right now.
You're gonna love it.